In this question, we determine the volume obtained by revolving the region bounded by y equals 4x squared, y equals 16, and x equal to 0 about the x-axis. So the axis of revolution here is x-axis, which means we utilize the formula to determine the volume of solid by revolving the region about x-axis is given by this formula, which is a definite integral from x equal to a to x equal to b, and then pi times of the big R of x quantity square minus the small r of x quantity square dx, where this big R of x represents the top radius or the radius of the top curve, and the small r of x represents the bottom radius or the radius of the bottom curve. And so, as we can see from the figure, r of x basically represents 16. So I'm going to write r of x. This equals, since it is y equal to 16, the height of this curve or the radius is 16. So we put r of x equal to 16. Now let's put the small r of x. From figure we see that the small r of x is the height represented by the curve y equals 4x squared. So we utilize 4x squared for small r of x. Now the limits of this function is from 0, this is a starting point, to this point, this is seen from the figure, this is 2. So a equals 0 and b equals 2. Now let's substitute these values into the volume formula. So therefore we write volume obtained, and this equals pi times of integral from x equal to a is 0, b is 2, and then the big R of x quantity square. So this will be 16 quantity square minus the small r of x, which is 4x squared, and this is a quantity square. We then put dx. So let's simplify and evaluate this definite integral. And though this equals pi times of 0 to 2, 16 square is 256 minus 4x squared, quantity square is the square of 4 is 16, and the square of x squared is x raised to the power of 4. When we apply the exponent clause and then dx, now we integrate the terms inside the brackets. So we can integrate this term and integrate this term. So I put pi times of integration of this is a number. So this is 256 x minus the integration of this one is 16 x raised to the power of 5 divided by 5. We add the power 1 to the 4 and divide by the same number. This is according to this integration law. That is, the power rule of integration says x raised to the power of n is x raised to the power of n plus 1 divided by n plus 1. So we place this formula to integrate x power 4. And then this must be evaluated between the limits 0 to 2. Now let's substitute the upper limit. And so therefore this equals pi times of 256, replace x by the upper bound, which is 2, minus 16 times of replace x by 2, so it becomes 2 power 5 divided by 5. And then we should subtract this by applying the lower limit. And when you put the lower limit, this term will become 0 and this term will also become 0. So it is simply 0. Now let's evaluate this. So this gives pi times of 256 times 2 is 512, minus this one is 16 times 2 power 5 is 32, and this is divided by 5, and 16 times 32 is 512, which we will put in the next step. So this becomes pi times of 512 minus 512 divided by 5. We can simplify this fraction. This one is 512 over 5 over 1, and so this equals, we multiply and divide by the common denominator. So this one will be, I can write this as 5 times of 512 divided by 5 minus this is 1 times of 512 divided by 5. Now we have the common denominator 5, so we can write like this: 5 times of 512 minus 512 divided by the common denominator 5. And so this is 5 times 512 minus 512, which we can simplify as this one is pi. This is 4 times of 512 over 5. And so this gives 4 times 512 equals 2048. And then dividing that by 5, we get 409.6 pi. Or otherwise, we multiply this pi quantity and approximate to 3 decimal places, we get 1296.796. We can put this unit as unit cube. And so this is the volume obtained.